Greetings of the day, dear students. In the previous video, we have completed the common base configuration, right? Now, in this video, we are going to discuss about the common emitter configuration. We will see its diagram in NPN mode and also in PNP mode, right? In NPN, what will be the circuit diagram? This is the circuit diagram, and in PNP mode, and the base current amplification factor beta, which is given by the change in output current to the change in input current. Here in this context, it is the delta IC by delta IB, right? And also we will discuss the relationship between the beta and alpha. At last, we will discuss the input and output characteristics of common emitter configuration. We will discuss the input and output characteristics of common emitter configuration, right? This is what we are going to discuss in this video. At last, we will see in another video, we will discuss the common collector configuration. Totally, this common base, common emitter and common collector configurations are divided into 3 videos as per your syllabus requirement, right? Yeah. Dear students, as we discussed earlier, for common base configuration, base is common for input and output. Here also, in common emitter configuration, the emitter, this is the emitter and this is the base and this is the collector. Right, this is the collector. Now in NPN configuration, for example, this is N, emitter is N, base is P and the collector is N, right? So here the emitter base will be forward bias, in the sense the base will be connected to the positive terminal of the battery and the emitter is to be connected to the negative terminal. Similarly here the collector will be connected to the positive terminal, N will be connected to the positive terminal and this will be connected to the negative terminal, right? Now here the emitter will be common to both the input and output. How do you understand that? The input will be given across the emitter base junction and the output is collected across the emitter and collector junction. This is R, indicates the load resistor R. Across that we can collect the output. Here the current amplification factor beta is defined as the ratio of change in collector current to the change in base current, and this is known as current amplification factor beta. So delta IC by delta IB gives you the value of beta. Normally some 5% of the emitter current flows to the base, so the amplification factor will be greater than 20, and usually this value changes from 20 to 500. This value will be very high. Whereas in the previous case in alpha, if you observe, that value is just some 0.9 to 0.99. Alpha lies in between 0.9 to 0.99 in common base configuration. But whereas this beta lies in between some 20 to 500. This is the circuit diagram for PNP configuration. If you observe, the base is this is the emitter and this one is the base and this is the collector. The base terminal is connected to the negative terminal and the emitter is connected to the positive terminal, right? Now here this P collector is connected to the negative terminal and the base is connected to the positive terminal. Across emitter base we are giving the input and across emitter collector we are taking the output. These two diagrams are important. While attempting this question in an exam, it is very important to draw the circuit diagram. For the diagram itself, you will get the more marks for common emitter configuration. Simply make emitter common to both the input and output. That's it. If it is NPN or PNP configuration, based on that you indicate the polarities. In both the cases, emitter base must be forward bias, emitter base must be forward bias, and emitter collector is to be reverse bias. Right? Now, what could be the relationship between the beta and alpha? What could be the relationship between the beta and alpha? Just now we have defined the beta is the change in collector current to the base current, but alpha we have defined in the previous discussion, change in collector current to the change in emitter current. But our transistor basics, the emitter current will be equal to the base current plus collector current. A small change in emitter current is equal to the delta IB plus delta IC. Based on that, delta IB is given by delta IE minus delta IC. Therefore, beta, in the place of in the beta, let me substitute delta IB value, which is nothing but here delta IC divided by delta IE minus delta IC. Right? Now, if you take out delta IE common, delta IE is taken out common from both the numerator and denominator. It can be written as delta IC by delta IE whole divided by delta IC by delta IE minus delta IC by delta here it is delta IE, this is delta IE, sorry, delta IE by delta IE minus delta IC by delta IE. So just now we have defined this one delta IC by delta IE as alpha. Therefore alpha by this becomes 1, alpha by 1 minus alpha. Very, very important. The relationship between beta and alpha is given by beta equals to alpha by 1 minus alpha. Beta equals to alpha by 1 minus alpha, where beta is the change in collector current to the change in base current. Alpha is the change in collector current to the change in emitter current. These two you have to be familiar. Right? Now, as we have discussed earlier, the collector current will be a alpha times the emitter current plus leakage current due to the minority charge carriers leakage current. Therefore, IE equals to IB plus IC. In the place of IC, we substitute alpha IE plus IC B naught. Therefore, if you take out IE common, IE into 1 minus alpha equals to IB plus IC B naught. Therefore, IE equals to IB by 1 minus alpha plus IC B naught by 1 minus alpha. This is the expression for emitter current in terms of IB and IC B naught. Now, we are familiar 1 by 1 minus alpha, right? 1 by 1 minus alpha, if you further simplify, we will get emitter current as IE equals to beta plus 1 times IB plus beta plus 1 times IC B naught. This is the relationship between the beta and alpha. Now, if you observe, just as we have seen for common base configuration, the input and output characteristics, here also for common emitter, this is the emitter is common, and here we are having the base and here we are having the collector, right? The input characteristics will be plotted across VBE and base current. Very, very important. What is the x-axis variable and what is the y-axis variable? If you are familiar, then it will be very easy for you to plot the graph. Input characteristics between VBE and versus IB. Now, whereas the output characteristics, you can observe, it will be plotted between the VCE, here the x-axis variable is VCE and the y-axis variable will be collector current. This is plotted between the VCE versus IC. VCE versus IC. Very, very important. Clear? Right. Now, if you observe the plot, up to certain point there is no conduction in the, there is no base current is flowing. but after crossing the certain point of voltage, the breakdown has occurred. All of a sudden there is a rise in the current, but it is not that much depending on VCE voltage. Even though it is 1 volt or 10 volts or 20 volts, there is not there that much change in the base current. The base current is not that much affected, right? So IB increases rapidly with VBE. This itself indicates, as there is a rapid increase in the base current, it indicates that the input resistance is very small. Very important. The input resistance is very small. And units for IB will be in the range of microamperes. IB is in the range of microamperes. This is important. IB is increasing rapidly with VBE, and VBE versus IB characteristics is called the input characteristics. If it is common emitter configuration, Similarly, with respect to the output characteristics, you can observe that for very small values of VCE, it is little bit linear, but after crossing certain point, even though the magnitude is 5 volts or 10 volts or 15 volts, the collector current is constant. The collector current is constant. This is the collector current, right? So IC varies linearly with VCE only when VCE is very small. Now as VCE increases, IC becomes constant. IC becomes constant. Up to certain extent it can be linear. Up to certain point it can be linearly increasing with VCE. But after a certain point the collector current becomes constant. 10 microamps. For different values of base current, you can observe the value of IC is increasing. With increase in the base current value, the value of the magnitude of collector current is also increasing. The magnitude of collector current is also increasing. This is the active region, right? And the region before this straight line is the saturation region, and below that one is the cutoff region. 3 regions you can observe. This is the active region, saturation region, and graph below this one is the cutoff region of the common emitter configuration. In this entire discussion, dear students, if it is common emitter, please remember what is the x-axis and what is the y-axis for input characteristics, and what is the x-axis and what is the y-axis for output characteristics. Simply to remember, for input characteristics, as the input is across base and emitter, emitter base will be the x-axis, and the current, base current will be the y-axis. For output characteristics, collector emitter will be the x-axis, and the collector current will be the y-axis. Clear? Right. So this is what about the common emitter configuration. Dear students, in the next video we will discuss about the common collector configuration. Right? Thank you.